practice writing equations for both an arithmetic and geometric sequence and then finding the nth term of each. So let's start by going over an arithmetic sequence. So we have the sequence 3, 5, 7, 9, and so on. We know it's arithmetic. We know we're going to be adding a number each time. And the number that I'm going to be adding in this case is 2. 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. So let's go over here and just fill in the information that we have. My A1 value, if you'll recall, is our first term. In this case, my first term is 3. Let's write that down first. Okay, my common difference is the number that I'm adding each time. So in this case, that is 2. And then I don't know what term I'm looking for yet, so we'll say that it's just going to be n minus 1. So this is what we call the formula of an arithmetic sequence. If I want to find a specific term, let's say I'm trying to find the 10th term, that means that my value for n is now 10. So I'm going to go up here and plug in 10 for n. Oops. So now instead of an n minus 1, I have a 10 minus 1. So use order of operations to simplify. 10 minus 1 gives us 9. 2 times 9 is going to give us 18. And then 3 plus 18 is going to give us 21. So the nth term of this particular sequence is 21. Now if I want to find the 19th term, make some space here, that means that now my value for n is 19. So I'm just going to plug in what I have and simplify. 19 minus 1 is 18. 2 times 18 is going to give us 36. And then 3 plus 36 gives us 39, meaning my 19th term is 39. Now remember, if you get stuck, you can just keep adding 2 until you get to the 10th term or the 19th term. But when that wouldn't work is if I asked you for the 1002nd term. So we need to know how to write the equations that model the sequence that we're given. Metric, meaning we're multiplying by the same number each time, so we have a common ratio. In this case, we're going to be multiplying by 3 each time. Now, if you ever get in a situation where the numbers are kind of hard to tell what you're multiplying by, you can always take, let's say, a term and divide it by the term immediately before it. I know that 54 divided by 18 gives me 3. So if you're ever given like weird fractions or decimals and you need to figure out what the common ratio is, this is a method that you can use. So I want to write the general equation for it. My A1 value is my first term, which in this case is 2. My common ratio is the number that I'm multiplying by each time, which in this case is 3. And then n minus 1. I don't know what my n is yet because that's the term that we're looking for. Now, if we look specifically at question number 2, it says find the 10th term. So we know that n is going to equal 10. So I'm going to have 2 parentheses 3 raised to the 10 minus 1. We want to simplify this exponent before we move forward. So I'm raising 3 to the power of 9. That comes first before we multiply. 3 to the power of 9 is going to give us this nice big number. And all that we have left is to multiply that by 2, which is going to give us, let's go ahead and write it down here, 39,366. So remember that geometric correlates with exponential, so our numbers are going to get really, really big the higher the term. Now, The next one tells us to find the 19th term. We know this is going to be a really big number. So in this case, my n is 19. So let's clear this out and plug in 19 in the place of n. Simplify your exponent first. 19 minus 1 is 18. We want to raise 3 to the power of 18, which gives us this nice number. And we still need to multiply that by 2, which is going to give us this. And that is how you find the nth term of a geometric sequence and write its equation.